Okay, so we started looking at the TypeScript language the last day. I wonder you've had maybe a little bit of time to go back over some of the stuff there and maybe look at the lab as well. Any questions, I wonder, from the last day? Anything that I didn't explain clearly enough, I wonder? No? Okay. So what we know is TypeScript uses this postfix syntax, as I call it, for indicating the type of a variable. Uh, let's see, sorry. Where do I have it? Yep, this kind of syntax here, that's fine. Although we then later on discovered that really in many cases, I suppose you'd almost say you don't need to be explicit about the type. You let the compiler infer the type. Um, Although when you're writing fairly intricate code, it's often a good idea every now and again just to check that it is inferring the right type on your variables. In the case of VS Code, using that Command K, Command I. Uh, and we also use this postfix syntax for our functions because we need to tell the compiler about the types of the parameters a function is expected to receive. And again, in many cases, we can either explicitly tell it what the return type should be or let it infer the return type. We have classes, we have interfaces, that's okay. We have interface data types, which is this way of declaring your own custom types for the data structures that are relevant to the particular problem domain that you're developing your application code for. That was fine. Type aliases. There's a small bit of an overlap between type aliases and interface data types, as in, for example, down here, we're using the type alias syntax for defining the shape of an object, which is exactly what we do with interface data types. But then there are many other uses of this type alias syntax, some of which we came across, and we'll see one or two others today as well. And there are others that we won't see. But so type aliasing is far more expansive than interface data types. And I did say as well that when you want to define the shape or declare the shape of an object, whether you use type aliasing or interface data types is of no, there's no difference between them. You can use them completely interchangeably. Type referencing, I've already talked a little bit about. Then we talked a little bit about functions, and there can be quite a lot of type inferencing um, taking place when you're using functions, as in, for example, let's see, what are we doing here? Boom, boom, boom. Well, there isn't an example of it there actually, but maybe I'll mention it again in a moment. Higher order functions is just like higher order function is not a TypeScript thing. It's a programming thing really. It's not even specific to JavaScript either. You have this notion of higher order functions in other languages as well. But in the context of JavaScript stroke TypeScript, a higher order function is a function that takes a function as an argument, although it could be more than one, but we don't see that often. And strictly speaking as well, a higher order function may even return a function as a return value. We don't see that either though, but it does happen. And the question arose, how do we, so if a function is a parameter and we need to declare the types of the parameters for our functions. How do we declare the type for a function parameter, which is we refer to as callback? And that was using this syntax here, which is it kind of borrows from the arrow syntax in JavaScript, if you're familiar with the arrow the arrow function syntax, because we're using the arrow there. But anyway, this is the way we declare the type for our callback. That's roughly where we left off. Again, just maybe that prompts you to ask me something, but maybe not. That you might have been unclear about the last day. No, I just want to go in here for 1 second. Okay, no, I'll just push on. The next thing I want to mention is what are called optionals. Optionals come into play when you've got an object shape and some of the properties in the object are optional, or they're not mandatory. How do we indicate that in our type declarations, whether we're using interface data types? We know now that we use interface data types, or IDTs for short, or type aliases for defining the shape of objects. So in the example here, right, I'm saying I'm defining a type called user for myself, and I'm saying a user has an ID property, which is of type string. It has a name property, which is of type string. It has an email property, but the question mark here is TypeScript syntax. That question mark is telling the compiler that the email property is optional, meaning that you're allowed to have instances of users who do not have an email property, and the compiler won't complain. Looks like the social property is optional as well. And the way you interpret what's going on here is the social property, if a user does have a social property, if an instance of a user object does have a social property, then it must be comprised of a Facebook property, which is mandatory, but the Twitter and Instagram properties are optional. And also there's a status property. Yeah? So this question mark is how we indicate what properties are optional in our object shape. We can use this optional indicator in functions as well. If you want to indicate that a parameter in a function is optional, then you use the question mark symbol for that as well. I'll have a look at some examples in a moment, but we'll push on the slides. Back to our type aliases idea, and two particular use cases for the type alias syntax are what are referred to as union types and type literals. We've actually seen these already, but I may not have given them their name, so I'm covering them more formally here. So a union type is a type whose values can be more than one single type. Examples always hopefully make things clearer. So I'm saying here, I'm declaring a type called size, and I'm saying it could be a string or a number. We said this last week, this is the R symbol. You're not restricted to two options. You could have other options as well. I'm declaring an actual variable here called glass size. Its type is size, and I'm assigning it the string medium. And the compiler is not going to complain because that's consistent with here. I've got another variable called bottle size. Its type is size, and I'm assigning it the number 2.5. And that's okay as well because number matches that. Just in passing, the clearly the compiler would not be able to infer the correct type for either of these two variables. If you took out size here, then the inferred type for glass size would be string. That's not what we want. And the inferred type for bottle size would be number, and that's not what we want as well. So that's a nice simple illustration of where type inferencing does not work. Um, oh yeah, here, just another example here, right? Uh, I'm declaring a type called role, and I'm saying it could be either student or lecturer or manager, and presumably student, lecturer, manager. Sorry, presumably student, lecturer, or manager are defined elsewhere, uh, either using type aliases or using interface data types. Doesn't really matter. And then I'm declaring an actual object called Jane. Its type is role, and let's supposing Jane is a student, and I have the various properties of student here uh, for that variable. Again, it's highly unlikely that the compiler would be able to infer the correct. In fact, it might infer that Jane is of type student, which isn't wrong, but for some reason we don't needn't go into it. I want to let Jane be its type to be role for whatever reason we needn't. Okay, so that's union types. Literal types is where you want to define a type and you want to be very specific about the values that instances of that type can have. Um, and again, examples are always easier than definitions. So I'm declaring a type here called degree nomination. And I'm saying the only values it can have are that, or that, or that, or that. Here I'm declaring a variable. Its type is degree nomination. I'm assigning it BSBeng. That's one of my literal types that I've up here. So the compiler is not going to complain. Now, it doesn't have to be strings, right? You could have numeric values, could be your literal type as well. Could even be a Boolean, but there are only two values, true and false, so it's unlikely you'd ever need to use Boolean values in your literal type declarations. Tends to be mainly strings or numeric values. Let's jump over to the code, although I think those two aspects of TypeScript are not particularly difficult to grasp. If I look at this sample here, there's our user, which we had in the slides. And here I've got a variable called Joe, and we can see Joe does not have an email, and Joe doesn't have a social property either. I'm saying Joe is of type user, and the compiler, there's no red squiggly lines, so the compiler isn't complaining. Got another variable here called Jane. Jane does have an email, but doesn't have a social property. I guess it is uh, obvious, or maybe not. Like there's no sense of the ordering of these. There's no sense of the ordering of these properties. Ordered is not relevant. If I just move that up, or look, if I switch these two around, I'm still not getting any compilation errors. So order is not relevant. I'd imagine people would have known that anyway. So that's Jane, and then we have Jill. Jill does have an email. Jill has a social property, and because she has a social property, there must be a Facebook. and the others are optional, although she has a Twitter as well, but she doesn't have an Instagram. So they're all valid instances of our user type. Uh, in relation to functions and the optional, so I've got a function here called print ingredients, and it has three parameters. It has the ingredients, which is in a string. It has quantity, which is string as well, and it has extra info, but the question mark here means that extra info is an optional parameter of this uh, useless function. And so down here, then I'm invoking the function. In this case, I'm giving it only two arguments, so I'm leaving out the optional one. In this case, I'm giving it three arguments, so, again, there's no squiggly line. The slides said it, although I skipped over it in this. I didn't mention it when I was looking at the slides, but the optional parameter has to be the last one. You cannot, for example, if I move this to be the second one, the compiler is going to complain. You can see lots of compilation errors coming in here. I thought it would have. Yeah, it's actually complaining here in the actual definition because it's really telling me you can't have an optional parameter in the middle of the parameter list. It can only be the last one. So we'll get rid of that. TypeScript has named parameters as well, but you can Google it yourselves. With named parameters, you actually specify here before the parameter value, you specify which parameter is this being assigned to. That's okay, I can skip over that. And, just some examples of the, what am I demonstrating there? Type aliases. Well, okay, let's just look at it. I've got a social handles property or type, sorry, which I just borrowed from above, really. Like it's probably not if I just scoot back up to the top. If you've got complex structures, this isn't complex, but by complex I mean a lot of nesting of objects within objects rather than coding them in a very kind of linear fashion here. It's better to define various kind of subtypes for your complex types. So that's what I'm getting at down here, right? I'm actually defining a type called social property so I can use it in a more complex type. So that social property, although I'm actually getting at a different point now in this illustration. So that's fine. That's social handles. I've also got an address type, and I've got a user v2 type, and the user v2 has a, sorry, I skipped over this one. I've got a contact type, which could be either social handles or address. I've got a user v2 type, and user v2 has a contact property of type contact. So it could be an address or a set of social handles. And then I've got an actual instance of user v2. So Kyle's contact property looks like it's of the social handles type. And I've got Jenny, and Jenny's contact property looks like it's shaped like an address. And again, no complaints from the compiler. It's able to follow all of that. Let's suppose I've got this function called getContact, and I pass it any user v2, and the idea is that it's meant to return the person's contact details, and I just arbitrarily decided I wanted it returned in stringified format. Right? I'm not returning a contact, I'm returning a string. So my function is going to kind of serialize the contact details. Now inside, so I'm passing in user v2, and that means that the contact could either be an address or it could be a social handles. And maybe the way I want to return the contact details will be slightly different depending on which type of contact it is. And that means I need to have an if statement in my code working out, well, what type of contact is it? So this is the kind of long-handed way of doing it. What I'm doing here is I'm checking, does the user.contact property, does it contain a uh, does it contain a property called street? And if it does, then we can deduce that that user's contact is an address. It's not a social handles. But the interesting thing is that the compiler can actually work that out as well. And that's really what I'm trying to get across in this simple little example here. So you can see here, look, I'm assigning user.contact to a variable. Now, if I do Command K, Command I on this, uh, if I do it on this, you can see it's worked out. It's actually an address type. It's not telling me it's a contact type. It's being more specific. It knows it's an address type. So in what it's actually doing, like, is it's following the flow of control. The compiler now is following the flow of control to work out the inferred type for this particular variable here. Yeah. Um, and so, right, and then this is what I'm returning. This is my string. This idea of the compiler actually following the flow of control and inferring uh, the address type is what we refer to as type narrowing. It narrows down the type from being of type contact to of type address by following the flow of control. That type narrowing, it can be a very useful aspect of the compiler. And down here, if I do Command K, Command I, again, if you follow the flow of control, because I do have a return statement here, so the only way the flow of control is going to get down to this line is if the contact is of type social handle. And again, we can confirm that. Yeah. What's also nice is, like, if I just stick in a line here and I go, I don't know, let t equals contact dot. See here how the compiler is telling me what are the only valid properties of contact here. It's not telling me that street is a valid property. It knows that these are the only valid properties. So this kind of, as we call it, IntelliSense that's built into your IDE, that's really being aided by the TypeScript compiler. And something as simple as that can avoid silly kind of coding mistakes that we often make in JavaScript. In JavaScript, if I had this exact same function, I might type in street here. Okay. And obviously I'm not going to get any indicator from JavaScript that there's something wrong until I actually run the code. Then I'm going to get contact.street is undefined. Uh, yeah. So that simple scenario uh, is where you kind of you see the benefit of TypeScript, the TypeScript language over JavaScript. Stops you making mistakes which you won't catch until runtime. Moving on. Okay, just an illustration of literal types. So I've got department, which is either engineering or this or that. I've got I'm declaring a staff member type here. This is just in passing, right? I'm using my user v2. This is obviously ANDing, so I'm ANDing this object structure with this one. So a staff member has all the properties of user v2 and also has a department property. And the department property is of type department. And then I create some, I have a company, which is an array of staff members. This dot dot dot, we defined Jenny and Kyle earlier on. This dot dot dot, you may know it's not a TypeScript thing, it's a JavaScript thing. It's called the spread operator. It essentially takes the properties of Jenny and spreads them out inside in this object here. I'm defining an object for myself. If I didn't use the dot dot dot, then what would happen is this object, sorry, this object would have a property called Jenny, and the value of the Jenny property would be the object that I defined earlier on. That's not what I want. I want the individual properties of Jenny to be included in this object. So name, ID, contact, all that kind of stuff. And then a department as well. Same for Kyle. So that's my company structure variable, an array of staff members. And let's supposing I have this function called get staff names, and it's a function. It takes an array of staff members. It takes a department parameter, and what it's meant to do is find all the people in this staff members array that are in the particular department and just return their names. Okay, that's the function I dreamt up for myself. So it's returning an array of strings, and the array of strings is meant to be the names of the members that are in that department. And the way I do it then is fairly straightforward, right? I filter over the company to find all the members that are in the particular department that I'm interested in, and then I map over the output of the filter. I map over that to just grab their name, and so it's the output of the map. That's what I'm returning back to the invoker, and it is an array of strings because staff.name is going to be a string, and map returns an array. But I mean, that's the code is just JavaScript, really. From a type inferencing point of view, if I select staff here, I do Command K, Command I, the compiler has followed the logic all the way through, and it knows that staff there is a variable of type staff member. So it never loses track of the types, even in something as arguably, complex as this. This is an entire statement, and it's still able to follow right through. Any questions so far? I'm assuming from a programming point of view, people are familiar with this method chaining, which is what I'm doing here. I'm chaining on one method invocation, chaining it down to another method invocation. Okay. The next topic is generics. Generics is not a TypeScript thing. Generics, many other programming languages have this generics feature in them. I think the first language I have it, I think, was C++. Java, I think Java is the first place I came across it, and that's not today or yesterday, so it's almost decades ago now. Um, so TypeScript has generics as well. And the idea here is, like in software development, we love reusability. We love writing components that are reusable. That's essentially what a function is, you know. It's what a class is. They're all reusable. But with generics, what we're trying to create are components that are reusable in terms of the types of data that they work on. So it's the data type is actually a variable, and we can assign different values to the type variables. Okay, which is kind of if you've never come across it before, you kind of get a little bit confused. So I'm talking here about the fact that we can have variables that are assigned a type. Normally, when we talk about variables in programming, we assign them a value, you know. But here we're talking about variables that we assign a type. And in that sense, whatever the nature of the component that we're developing, the variables of this component will be type-related variables. Right? The component could be a class, it could be a function, it could be an interface data type, it could be a type alias, as we'll see one or two of those examples. We won't see all of them though. Here's an example, and again, the initial examples usually are useless, but it's the syntaxes. We just want to get familiar with the syntax first. So here what I want to do is I want to use this generics idea for a function. So I'm declaring a function here called process. And this syntax here, the angle bracket, close angle bracket, and this t here now is a type variable. It doesn't matter what you call the variable. Conventionally in TypeScript anyway, we tend to use capital letters, single capital letter names for our type variables, like T and U and V tends to be the ones that are used, but it's completely arbitrary. So T here represents a variable, and it's not a variable that can be assigned a value, it's a variable that can be assigned a type. But it's a function, and the function, it looks like it takes two arguments. The second argument is a type number. The first argument, though, is of type T. So we're borrowing the T from here. Doesn't really matter now what the function is doing for now anyway. So that this is a declaration of a function, and we would say it's a generics function. It's a function that is utilizing generics, as is evidenced by this bit here. Here's where we're actually invoking the function to execute it. And here is where we assign something to T. We assign something to T. And it looks like in this particular invocation, we're assigning person. So presumably person is a data type that we have defined somewhere else in our code using, let's say, the interface data type syntax. So a person has a name, an address, and blah, blah. Yeah. And we're passing two parameters, person X and 5. And presumably person X is an actual bog standard variable that we have defined, that we've declared somewhere else, and we've assigned it a value, and the value that we've assigned it is an object of type person, otherwise the compiler is going to complain. Here's another invocation of the same function, but this time we're assigning the type box to T, and we're passing it an instance of a box and a value. So it's the syntax anyway is all I'm trying to get across here, how we recognize generics. Clearly, like how you actually process T, because in the middle of this function now, T could be, well, it can't be any type at all. Maybe there are some constraints on it. I'm not putting any constraints on T up here, on T here. Usually there would be constraints on it as to what types we can assign to T, and that would help us then in the actual implementation. We won't get into the detail of that. I guess all I really want to get across is that you understand the syntax or you recognize the syntax of generics. I don't see writing functions or any type of components uh, yourselves that will be generics based, but you certainly will come across them and you will be using them, but you won't be creating your own. Again, I had to try and dream up uh, an example. So so let's just park generics now for a second, and we'll come back to it. Here's just uh, plain old JavaScript, really, right? I've got an array of strings, um, and I'm calling the JavaScript sort method on this array. And we know from using the sort method before that the sort method expects a function, and the function essentially kind of describes how the elements in this array should be sorted. And by default, it sorts them in ascending order. And it looks like from the function, we're comparing the length of adjacent strings in our array to determine whether the position of two adjacent strings should be flipped or not. Yeah? I'm assuming people are okay with all of that, right? So I've just decided that length uh, is the factor that determines the sorting. That's okay. There's no generics going on there. So a console log of this and my source array, what do I call it? Some strings dots, some strings. I don't know. Oh yeah, sorry. Uh, sort does mutate the array. It doesn't return. I've forgotten what it returns actually, but it does actually change the array itself. A lot of these methods in the array type don't actually mutate, but they do in this case. So um, clearly, what this is going to finish up as, it's going to put, what's my original array? It's going to put t first in the array, the next, hello, and then universe, I guess. Let's just make sure and go ts npx ts node 03 and surprise, surprise. Okay, so that works. That's fine. But that is just plain old JavaScript, so there's nothing terribly interesting there. Here I'm defining my own function for myself called string ranker. And it's a function that takes two arguments, it looks like. It takes an array of strings and it takes a callback. And the callback is meant to be, I'm going to be using the callback to control the sorting of this array. And the signature for the callback is it takes a string and returns a number. Right? The callback has to honor that, otherwise I won't be able to use it in the sort because that's the way that's what the sort expects. And it returns an array of strings. So that's fine. And here I'm actually using the sort again for my array of strings, and same as before. And I'm using Ranker here now. So it's slightly better, you know, not that much, but I'm using Ranker here. And I'm returning result, that's fine. Here I'm actually invoking my string ranker function and passing it in this array of strings. And again, I'm actually using, here's my function, my ranker function. It takes a string and returns the length. Now, if you're thinking to yourself, isn't that exactly the same as what you've done at the top? And you're right. But we're building up to something here, right? We're building up to generics. Okay, so I've got this string ranker function that does what it does. And I'm invoking it, and let's assume it works fine, which it does. In fact, we can see down here, we can see from here, like it worked fine. I've got another function called person ranker, which kind of does the same thing as the string ranker, but it's working with a different data type. It's working with an array of person objects. And my ranker function, the ranker function always has to be, because I'm using sort, the ranker always has to be something that returns a number. That's the most important thing, because that's how sort works. But the argument is of type person. Okay, so that's okay. The body of this function is, the body is almost the exact same. In fact, it is the exact same. Right? There's the body of the function. It's the exact same as the body of the string ranker function. Sorry, the string ranker function here. So that's kind of indicating, hang on, could we bring these two functions together and define them as one thing? And that's where generics will come in, but we'll get there eventually. So I've got my person ranker. I've got a person, by the way, is defined just as a data type. Let's just be clear on it. There's a person there, yeah. So they have a first name, a last name, and an age. The age is mandatory for now. Let's go back to where we were. That's not where we were. I'm going to close that off, sorry. Right, that's person ranker. And then I'm actually invoke. Sorry, that's not person ranker. This is person ranker. And I'm creating a person object for myself. So I have Joe, and I have Jill, and I have Jane. And I call my person ranker function. I'm passing it my array of 3 people, and I've arbitrarily decided, hardly surprised, that I'm going to use age as the ranker. But the signature of this function, sorry, this actual function, this is an actual function, okay? Its signature respects what I've specified up here. It respects this signature. It's a function that takes a person and returns a number. It happens to be a one-liner, okay, p.age, but it doesn't have to be a one-liner, but it just happens to be a one-liner in this case. And I guess then when I do console log and I invoke my person ranker, I essentially invoke this function here, then I would expect to get the array back in the right order. And if we scoot down to the bottom, we can see from here, right, that it has ordered them correctly in ascending order of age. So that all looks good. We still haven't got to generics though. Can I also mention something else which also has nothing to do with generics? I'll get there eventually, but it actually highlights another aspect of TypeScript, which we haven't seen so far, which can be extremely useful as well. And so what I mean by that is if we go back to the person type, right? And let's supposing age was an optional parameter. Okay, we're all a bit vain. So let's say age is optional. How does that impact on what we've been looking at? Well, we certainly have looks like we've got a compilation error. So where's the error? Let's just use it here. And it's saying down here that the type number or undefined is not assignable um, to type number. So up here, I'm saying my ranker function has to be a function that takes a person and returns a number. That's all. It has to honor that signature. My specific ranker function, this is it here. P is definitely going to be of type person because, well, okay, it's going to infer it, but p.age looks like it's going to be number. So what's the problem? Does anybody have any idea as to why is it complaining? It's saying that this function is not a function that takes a person and always returns a number.
But it can't return a number if the number isn't there, if it's optional.
Correct. Right. So if person's age is optional, then really the value is going to be undefined. So this function that I have could either return a number or it could return undefined. And that doesn't match up with my callback signature up above. Now it's small in this case, right? But that's another typical cause of errors in JavaScript programming, and the compiler spots it. Now, I've just arbitrarily decided to deal with that. I mean, I could either say make age mandatory, but let's supposing we're told no, age has to be optional, then I have to come up with some other way of dealing with it. And I've just arbitrarily decided this is what I'm going to do. I'm essentially checking, does the person have an age property? If they do, then use age as their actual age as the return value. Otherwise, I've arbitrarily decided 30, whatever, 30 is going to be the numeric value returned. And, if we, let's say, take one person, doesn't really matter who, and take out their age, then everything is going to work fine for me. Let's go back to here, run it again. Okay, and it's working from here. Right. Will he ever talk about generics? Well, let's talk about generics. So clearly the person ranker and the string ranker, it should be possible to kind of merge those into one. And so here I've got generic ranker. Here I've got my T. Again, it could be any name. It takes two arguments. It takes an array of T's and it takes a ranker. The rankers is a function whose parameter is of type T and returns number. And the body looks like this. Yeah. And here we're actually invoking our generic ranker. We're saying T is of type person. And I'm giving it an array of persons. And I'm giving it my ranking function. So everything is hunky-dory, and when I actually invoke it, you can see down here that it actually works. For my string case, my uh, string by length, yeah, okay. I'm using my generics and giving it an array of strings. Now, notice here though, here, I, I'm not telling it that T is of type string. Up above, I told it T was of type person, but I'm not doing it here. But it does seem to work okay, you know, as we can see down here, it's actually working okay. And this is another example of type inferencing. Let's try the Command K, Command I. Yeah, see how it worked out there, that T was of type string. And really what the compiler did was it more than likely looked at the array. Sorry, no. Am I looking at the right one? Yeah, it more than likely looked at this array and saw that it was an array of strings and then inferred that T must be of type string. So, all right, so that's generics, a very simple, fairly kind of 101, admittedly, example of using generics. And I'm using it in the context of a function, but you can use generics in other areas for other components as well. For example, here, okay, I've got a microphone data type. I've got a speaker data type. I've got a box data type, but it's actually a generics interface. So it could be a box of anything. A box always has a shelf name or a shelf number, and it has a content, which is an array of T's. And here's a particular box, which looks like it's a box of speakers. And my contents, these objects, well, there's only one, but it does match the speaker structure. So we can use generics for data types as well. Where you see them a lot is with classes, with type aliases, right across the board. You will see them you see them a lot in functions actually later on, mainly, and in data types as well. Okay, that's generics. Uh, the last thing I want to look at, just because we need to push on from TypeScript really, but because there are many other aspects, really nice aspects of TypeScript that we won't get to see. But for now anyway, there are these what are called utility types. So the language itself, the TypeScript language itself, clearly it has inbuilt native types, which we talked about way back, as well. Built into the language are kind of useful other types. For example, the regex, which I just mentioned very briefly way back. The regex type, it's not a primitive type, but it's just a useful type that's built into the language. And there are one or two others as well. But in addition to those other useful types, there are also a set of what are referred to as utility types built into the language. There are utility types that have been developed by the community, but they're sort of outside the language, so you'd have to install the relevant third-party library to access those. But they're quite a good selection of utility types, as they're called, built into the language itself. And a utility type is a type that you can use to transform one type into another, to transform one of your own custom types into another custom type. So it's kind of a shorthand way of transforming custom types of your own into other custom types rather than doing it kind of by longhand, if you like. The screenshot is just from like if you Google TypeScript utility types, which I did just before we came on air. So I just Googled this and it brings you straight to the TypeScript online documentation, and it tells you here all of the built-in utility types that come with the language. Now, just to give you some illustration of a small subset of those, it's kind of the most commonly used ones. So let's see. We've got a tech user here, just a standard custom type of mine. So tech user has these properties, name, ID, and an array of, let's say, programming languages, and an email, which is optional. Okay. Then I want to define a type for myself called tech user optional. And the idea is I want this tech user optional to define a data type which has all of the properties of tech user, but I want all of the properties to be optional, right? So rather than sort of cutting and pasting this and using my question mark, I can use the utility type called partial, and I give partial the kind of the base type, if you like, tech user, and we recognize the generic syntax here. And so if I do Command K, Command I on tech user optional, you can see it has all of the properties of tech user, but they're all optional. So obviously that's something that I needed in my application. So that's the partial utility type. The okay, that's just a function using it. That's okay. You can look at that yourselves. The op um, the alternative to that is there's this required utility type which takes your base type and it makes all of the properties mandatory. So we had email above, I think, which was optional in the base type, but it's not optional here. Email is mandatory. That's required. Pick is another utility type. The idea of pick is that you take the base type and you just pick a subset of its properties and you put those into the new type that you're defining. So what did I call it? Minimal tech user. Don't know where I come up with these names. So the way you interpret this is, unfortunately, now this is not, you don't interpret this as the or. It's really kind of an ending. There must be some reason why the compiler, why the designers had to use the or symbol here rather than the and symbol. So it looks like I just want to pick out email and name from this base type. And so if I do Command K, Command I on this, um, did that work? Command K. Yes. So that's pick. Omit. Okay, I'm using it there. That's all right. Omit is the kind of flip side of that. Sometimes it might be easier to use omit rather than pick. What omit does is it takes the base type and it omits from it the ones that the properties that you list here. So this type now is going to have all the properties of tech user except these two. That's omit. And so you could easily read through these yourselves and you'd kind of you'd work out how to interpret them. They're not that challenging. The last one I'll mention, which is slightly uh, off center from the ones that we looked at so far. The ones that we looked at so far are pretty straightforward. Uh, there is this type, the utility type called record. And maybe if I show you what I want to produce first. So if I just run, if I run this script itself, npx 04. Okay, so see this object here, right? And it's an object, and what it is the entries in the object, the keys are going to be the ID of a tech user, and the value is an object that contains certain properties of tech user. So it's actually kind of a lookup map, right? So that's an actual data structure that an actual data structure, yeah. No, sorry, it's an actual uh, piece of data that I want to create. But the question is, from a TypeScript point of view, how do I declare the types of the entries in this object? I know kind of in English that each property in this object, its key will be taken from the ID of a tech user, and its value will be an object which has just a subset of the properties of tech user. But can I describe that from a TypeScript type perspective so that I can ensure that there is no entry, there's no property in this object that doesn't follow that structure? And that's where this record utility type comes in. So here I'm using it, right? So I've defined a type called tech user map by ID. So that's this tech user map by ID. That's the name I've dreamt up for the shape of each entry here. Yeah. And so the way you kind of read it is uh, the keys have to be match the type of the ID property of tech user. This part here, tech user subscript ID, that's just kind of JavaScript syntax. We're picking out a particular property in tech user, the ID property, but it's the type that matches is what we're interested in here. So that's, if we go back right to the top, ID we said was of type number. So the keys have to be of type number in my structure. And the values have to be of this shape here, tech user programming, which I defined earlier on. If you look back through this script, tech user programming is the data structure, which I'll kind of cheat and I'll just say it has a tech user's name and their array of programming languages. Right. So what? So that's what um, this record utility is used for. It's a way of declaring the particular properties of an object and what the nature of the key of each key in that object should be, and what the nature of the value of each property in the object should be. And all I'm doing here then is I'm just creating an instance of it. So, this is just an ordinary function, but I'm using this type that I've defined for myself. What am I doing? I'm this function map make map by ID. It takes an array of it takes an array of tech users, and it returns an array of my my new type that I've defined for myself. Sorry, it returns an instance of this type for myself. And I'm just using the map. I'm using the array reduce method to do that for me. This is just JavaScript, right? I'm not sure if I've gotten that, made that clear to you now or not, but well, I'm going back over it again now. I'll just pause for a second. I don't know if it triggers any questions that will help me to clarify what I'm trying to get across here. No. Okay. While I wrap it up, I'll say, like, in the case of interface data types, what we're defining is an object, and we're being specific about the keys and the types of the keys. Like for, let's say, user must have a key called ID. Its type must be number. It must have a key called name. Its type can be string, etc., etc. So that's interface data types and type aliases. Here, though, what I want to do is I want to somehow help the compiler to work out what are the shapes of each property in this object. And that's what record is doing for me. It's allowing me to be specific about what is the nature of the key of each property in this object, and what is the nature of the shape of the value of each property in this object. Right, if I keep talking, I'll just only confuse myself, that's it. That's utility types. And that's all we're going to look at in relation to TypeScript. So now if I go back to the lab, you can now complete this lab, as you can see here on the left, looking at all the aspects of TypeScript which we've looked at. And there are many other aspects, as I said. So see how you get on, work your way through the lab, and there are exercises scattered around there. So it's not all just cutting and pasting. Okay, let's park TypeScript, although we'll obviously be writing lots and lots of TypeScript during this module. I want to move on to the next topic, which again is kind of foundational. And it's where we move into the world of cloud. So I want to talk a little bit about the Cloud Development Kit, or the CDK. Let's forget about the labs for now, I suppose. So let's talk about, let's look through the slides and explain what this is all about. So we're switching focus now to the whole cloud notion of the cloud, and in particular we're looking at the AWS cloud platform, because this cloud development kit, or the CDK, it is specific to AWS. You can't use it with the other cloud providers like Azure or Google Cloud. And the context for all of this is, so when we talk about the cloud and we talk about creating infrastructure up in the cloud, by infrastructure we mean, for example, in the case of AWS, creating an S3 bucket, creating an IAM policy, creating an SQS queue, creating an EC2 instance. These are all what we call infrastructure but the way we create them clearly, because we may need to create the same set of infrastructure resources multiple times, maybe because we want to have the set of resources which we're going to use for development purposes. When we're developing an application, we're going to be deploying our application to that infrastructure. So during development, we need to create that infrastructure. Maybe when we're in test mode, when we're testing our application, we want to create the exact same infrastructure that we had during development. And also, of course, we want to create the exact same infrastructure for our production environment. So we need to have a way of ensuring that the infrastructure is identical for those three environments. Also, we know the way the AWS cloud is broken up into regions globally, and we may want to duplicate the infrastructure in multiple regions so that we can run our application in multiple regions. So either way, whatever way we create our infrastructure, we want to be sure that it's consistent and it's reliable, that the actual technique that we use or procedure that we use for creating the infrastructure is reliable and it's consistent. We're creating the exact same infrastructure every single time. Now, clearly, doing it in a manual way doesn't guarantee in any way consistency and reliability. So that's probably not an option, no matter how well you might document the manual steps to creating that infrastructure. You know, if you want to change the infrastructure, you've got to make sure that the document is updated, and you've got to make sure that everybody has the exact same copy of the document and all that kind of stuff. So it's not a runner really for a manual approach. We want to automate the creation of our infrastructure. Or put another way, we actually want to be able to write code, and the purpose of the code is to create the infrastructure. It's not functionality that we're developing in our code. The purpose of the code is to actually talk to, in our case, the AWS platform and get it to create the infrastructure for us. And code is something that, when we run it every time, it will do the same thing every time. So that looks like a better approach. And this code or this technique is what we refer to as infrastructure as code, or IAC for short. And you've probably heard of infrastructure as code already, certainly if you did the cloud architecture module in the previous semester. Okay, so infrastructure as code allows organizations to automate the creation of cloud infrastructure. And we have all the advantages then of actually codifying or automating, and the advantage being, what we talk about a single source of truth. It's code, just like any other code, so we can store it in a remote repository like GitHub, and everybody can pull from that repository, so everybody's getting the exact same version of the code. We can use version control on it, so clearly the code might evolve over time, and that would mean that every time, that we're changing the infrastructure if we make modifications to our infrastructure code. And of course, when we make changes to the code, we may introduce bugs, but of course, version control tools allow us to easily roll back our code. So we have all of those benefits. We get all those benefits from automating the creation of our infrastructure. So this idea of infrastructure as code has been around for a while, but it has gone through a number of evolutions. And in the next 2 or 3 slides, I'm just quickly going through the different generations of IAC. Originally, the way we did this was, so on the right here, I'm showing you, we've got the different AWS services like EC2 and SQS and S3. These are the AWS or the cloud services that are available to us. Now, what AWS did and the other cloud providers as well was in order to allow us to, if you like, talk to these services across the network, they actually wrap each of these services in a web API, a RESTful web API. And they also created a software development kit. And the software development kit allows us to easily communicate with these services. The very first software development kit that AWS provided was what's termed the Boto3 library, which is a Python library. So in the very early days of infrastructure as code, it was nearly always written in Python, in the case of AWS anyway. So what you had to do was you had to write a Python script, and you may have done a little bit of this in the cloud infrastructure module last semester. You had to write your Python script using the software development kit that was made available by AWS, the Boto library. And when you ran the script via the SDK essentially communicated with particular services, asking it to create instances of resources. So you might use the S3 part of the SDK to talk to the S3 service to get it to create an S3 bucket with a certain configuration. All right. And so your Python script could talk to multiple services, and you ran your script and it created the various infrastructure resources for you, hopefully anyway. But of course, you're communicating across a network here. So maybe when you run the script, it runs halfway through and creates what resources it is created so far. But then for whatever reason, the Python script crashes. So that means now you're kind of halfway. You've got some of the resources, some of your infrastructure has been created, but the rest hasn't. So you've got to go back now manually and delete the resources that have been created so that you can run the script from start again. Okay, so it just got very messy. Also, let's supposing you ran your Python script and it created all the resources correctly for you. Later on, you might want to change the configuration of some of those infrastructure resources or add new resources. So, okay, you can go in and edit the Python script, but if you're going to run it from scratch again, that means you have to undo all of the resources that were created. And so, the long shot of all of this is that this really wasn't a satisfactory solution to our infrastructure as code objective. Lots of problems with it, which I'm kind of documenting here. Now, AWS's and the other cloud providers, their response to that was to create a special service called the Resource Provisioning Engine service. And the Resource Provisioning Engine service in the case of AWS is CloudFormation. So this is kind of what I'm calling the second generation of infrastructure as code. Other articles that you will read will say, really, this was the first generation. The Python scripting approach that I talked about on the previous slide, that really didn't cut it and could hardly be classified as kind of the first generation. But that doesn't matter. I am calling it the first generation. The second generation is utilizing this resource provisioning engine. Now, the way it worked, as you may know, is what you as the developer did was you wrote either in YAML or in JSON, you wrote what was called a CloudFormation template. And this template code, okay, it's a stretch to call it code, but yeah, I suppose it is. It's declarative rather than imperative code. This code declared the resources that you desired. And you passed this CloudFormation this CloudFormation template, you gave that to the CloudFormation service, and it then took care of communicating with the other AWS services. Whereas in the Python scripting, all Python script via the SDK, it was talking directly to these services. Now you've kind of got an intermediary. And the CloudFormation service is actually using the SDK, right? But we no longer need to use the SDK directly. We're writing these CloudFormation templates. We're passing them up to the CloudFormation service, and it is sort of interpreting the template and calling the various AWS services to create our infrastructure resources for us. So it's doing the heavy lifting, if you like. Now, you may know that another company called HashiCorp, these CloudFormation templates were quite long and difficult to debug if the actual infrastructure that was created is not what you desired. You kind of had to work out where in my template do I need to make changes. So it was difficult from a programming point of view to debug these things. And so HashiCorp, the separate company, essentially kind of came up with a more shorthand version of this. It was still written in YAML or JSON, although I think mainly YAML. But you didn't have to write as much YAML code using the HashiCorp approach. HashiCorp had this language called HCL, HashiCorp Configuration Language, I guess it stands for. And I don't want to dwell too much on this. You may well have come across this HCL in the Cloud Architecture module, but essentially this script, this code was essentially converted into a CloudFormation template by the Terraform tool, and then the CloudFormation template was given to the CloudFormation service. So we no longer had to create these, we created these instead. And there was just simply physical less coding. But it was still declarative, this stuff. And declarative code is always more difficult, arguably, to write than imperative code. But I don't want to talk about HashiCorp. I want to focus on this part here, though. So CloudFormation template, written in YAML, give that to CloudFormation service. The CloudFormation template essentially declares the infrastructure that you require in a declarative way, and CloudFormation took care of the rest. Certainly this resource provisioning engine approach was a significant step in the journey towards an infrastructure as code, a kind of viable infrastructure as code solution. In the sense that if you wanted to update your infrastructure, all you had to simply do was, I go back again, go back to your original template, make edits to it, give that updated template to CloudFormation, and it actually worked out what updates needed to happen to the actual infrastructure. It took care of that for you. Essentially, all you're doing here, as you may know, is all you're doing in these templates is declaring what is the state of the infrastructure that you desire. By state, we mean what's the configuration of the various pieces of infrastructure? What's the configuration of your EC2 instance? The configuration of your S3 bucket? That's what you're kind of describing in these templates. And if you just change the template, then clearly some changes need to happen over here. But you let CloudFormation work out what are the changes that need to happen. So that was a massive benefit of these resource provisioning engines. And they're also, the provisioning engine, CloudFormation, in the case of AWS, was highly consistent and reliable. The downside was, though, that the actual YAML code that you had to write was quite long-winded, difficult to debug. There were no kind of abstractions available to you. We love abstractions in programming. Kind of abstractions kind of take away that some low-level detail, which may be difficult to debug. It takes care of that, some of the heavy lifting for us. This is a summary of where we are so far, right? So I did say to you that the first thing that the cloud providers did was they essentially wrapped the various services, in the case of AWS, the EC2 service, the S3 service, the SQS service. It wrapped them in a web API so that we could actually communicate with them programmatically rather than manually going into them. It published or made available an SDK which took care of talking to the web API rather than us having to programmatically communicate with the web API over kind of raw HTTP requests. The SDK shielded us from that. Then the resource provisioning engine idea came along, and it now kind of uses the SDK for us and takes care of that ugly part of the solution. And I'm saying over here that the resource provisioning engine, what it's really all about is it's about managing the state of your infrastructure. State again meaning what are the particular infrastructure instances and what is the configuration for each of those. That's what we mean by state. And it manages the transition of the state, be it forward or backward if you actually want to undo some changes to the state. You essentially describe the new state that you want, and it takes care of working out how do I communicate to the actual AWS service what changes it needs to make via SDK and Web API. But up here, we are still writing YAML code. And this is where the Cloud Development Kit, or CDK, comes in, which I'm calling the third generation. And in terms of our diagram, the CDK, we no longer now have to write YAML files, which we give to the CloudFormation template. What we can now do with the CDK is we can describe our infrastructure using an imperative language. And there are many options available to us, including TypeScript. Other options would be Python, Java, C#, Go, Rust, pretty much Kotlin, any language that you want to, you can use with this Cloud Development Kit. And in your code, let's say it's TypeScript code, your TypeScript code now is declaring the infrastructure that you desire and the configuration for that infrastructure. And the CDK converts your imperative code into CloudFormation template, and then the rest is as before. Gives the CloudFormation template to the resource provisioning engine, and the rest is as before. So the difference between this part of the onion and this part of the onion, the similarity first is they're both concerned with describing the state of the infrastructure that you desire. But here we're describing the state in an imperative programming language. And we've, as developers, we've got lots of experience of imperative programming and the benefits of imperative programming as well. Like when we were looking at TypeScript there, the idea that the compiler is checking that your TypeScript code is syntactically correct, and semantically almost as well in terms of the data types and all that kind of stuff. You don't really get that when you're writing YAML code. Okay, so yeah, so that's kind of the main benefit of using something like the CDK. CDK, as I said, is specific to AWS, though. There isn't an Azure equivalent of it. And so, the CDK framework, built into it, it has lots of class. It has a large class library, which we'll see. It has lots of abstractions, which make it simply means that we have to write less code as we did using the kind of CloudFormation template approach, because CloudFormation templates don't tend to avail of any kind of abstractions. And by abstractions, we mean, that certain default values for the configuration of certain resources, certain default values are assumed. You can override them, of course, but the most common values for configuration settings are built into the abstractions so that we don't actually have to specify them. And so overall, there's a better developer experience for the reasons that I kind of alluded to along the way, IDE hinting and IntelliSense and all of that. Better developer productivity because we're writing less code, just simply less lines of code. Okay, there is some testing support built in as well, but we won't get a chance to play with that. So where we are is we are going to be developing our infrastructure as code using this Cloud Development Kit. And the CDK has certain programming constructs that we use in order to use the CDK. Now, of course, when you're ever writing code, we're always talking about an application is a construct that we're very familiar with. The application in this case it's not so much the application contains functionality. The actual application describes the infrastructure that we want. Okay, but we're still using the word application because we're familiar with that term from programming, so we can't get away from that. So when we talk about a CDK application, it's not an application that has lots of functionality. It's an application that describes infrastructure. An application is made up of stacks. We'll see in a while that there is a class built into the CDK framework, a stack class. We define our own stack class. So an application is made up of one or more. That's what I'm trying to get across here. An application is made up of one or more stacks. Stack is a term that's used in the case of CloudFormation templates, as you might remember if you did that module in the first semester. A stack is made up of constructs. It's a fairly kind of generic term now, admittedly, but I'll elaborate on it a little bit. And again, there is a class built into the CDK framework called the construct class, and we can extend that class specific to our needs. And lastly, we have resources. Resources are the actual entities that are created in the cloud. So a resource might be a particular EC2 instance, a particular SQS queue. So this is kind of these are the high level concepts, programming concepts that we talk about in relation to the CDK framework. We create a CDK application. Our application is made up of a number of stack constructs. A stack construct is made up of a number of constructs. And a construct is made up of a number of resources. We don't tend to see resource specific code in our CDK application. What we mainly see are construct code. And this is kind of a visual representation, yeah. So we've got the app, our application is our kind of top level construct made up of stacks. Stack is made up of constructs, and a construct then is made up of particular, this is meant to represent particular pieces of infrastructure, like, what is it, an SQS queue, a Lambda function, which we'll see a lot of, an S3 bucket, a particular S3 bucket. Or, what I mean by what the construct will do is when the application is executed, this construct will create will have the effect of creating an SQS queue up on the cloud for us and creating a Lambda function instance. And so what I'm getting at over here is when we run this application, we run it locally. When we run it locally, behind the scenes, what the CDK framework is going to be doing is it's going to generate the CloudFormation template. It'll upload the CloudFormation template to the CloudFormation service, and the CloudFormation does what it did before with the CloudFormation template. I'm saying here a stack is the unit of deployment. So you don't have to run the entire application. Well, sorry, when you run the application, you can tell it, do you want it to kind of execute all of the stacks or only some of them? And that controls, what particular resources you want created. In our case anyway, our apps will only have one stack, but you can have multiple stacks within an application. But from a deployment point of view, you can deploy individual stacks or deploy all of them, whichever is appropriate. I talked about the developer. How are we on time? We're fine. The developer experience and developers' productivity. This is just a simple comparison. This is actually CDK code. I mean, we needn't look at the detail of it now. We'll look at it later on, but essentially there's 12 lines of code. This is my CDK app. It just has one stack and it's only using one construct, as it turns out. The construct that has the effect of creating an EC2 instance. And this is some configuration for my EC2 instance. But it's only 12 lines of code. When I run that, behind the scenes, the CDK framework will create the CloudFormation template, which is over here, but it has this number of lines of code, so from a productivity point of view, using the CDK framework, arguably you're much more productive than you would be if you're writing raw YAML syntax. I don't want to overstate that though, but I think it's a nicer experience anyway. The CDK execution flow, I've kind of covered this already really. So here you are, developer, you're writing, in our case, we're going to be writing TypeScript. We're going to be writing a CDK app in TypeScript. That script, that application, we can give that to the CDK framework, or essentially the CDK framework can kind of take that, generate the CloudFormation template. The CloudFormation template is uploaded to the CloudFormation service. The CloudFormation service then takes care of interpreting this. So it'll talk to the relevant services like EC2, SQS, S3, and the services, they take care of creating the actual infrastructure resources. Okay, what's next? CDK workflow. So you do install the CDK. The CDK has a CLI, command line interface, which you do install, and you'll be doing that in the first lab accompanying this set of slides. Probably you may get to the lab this week, and we'll see. So the workflow is, first of all, you need to create essentially an empty CDK app. So that's what I'm doing here, CDK init app. You need to tell it what language you're going to be writing your CDK code in, because as I said, there are many options available to you. We'll be using TypeScript. So the effect of this is, behind the scenes, the CDK CLI will scaffold a project for you, a CDK project. And, like all of these scaffolding, it has a kind of predefined folder structure, which we'll look at in a second. You write some infrastructure code, presumably, and you can, although I hardly ever do it, you can go CDK synth, and what this will do is it will look at your code and it will generate the CloudFormation template, which you can look at. Now, I've never done that, but I guess if you're very familiar with CloudFormation templates, it might be a nice thing to do, but I certainly don't. So I nearly always skip this step. The next step tends to be CDK deploy. And what that does is it looks at your code and it essentially, if I go back one slide, it essentially does all of this, right? It takes your code, generates the CloudFormation template. It will store it locally on your local system, but and it will talk to CloudFormation service, etc., etc. So that simple command, CDK deploy, triggers the ultimately the creation of your infrastructure, which you could then check manually, right? Maybe you want to make some changes to your infrastructure. So you go back to the code and you make the relevant changes. And you just do CDK deploy again. It will create an updated CloudFormation template, give that updated CloudFormation template to CloudFormation service. And as I mentioned before, the CloudFormation service, like that's always there in the background. It's really the CloudFormation service that's really doing the hard work. CDK framework doesn't get rid of that. CDK framework is just makes life a little bit easier for us, the developer. But when you do CDK deploy, it's as if the framework knows, well, I've already deployed this, so all I'm doing is an update here, kind of, right? But you don't have to tell it. It's not CDK deploy update or anything like that. There shouldn't be a dot there, but that's a typo. If you want to remove all of the infrastructure that has been created, all you've got to do simply is CDK destroy. I guess it's probably obvious, but each of these commands, you need to submit these commands from the base folder of the project that was created up here. I guess that's kind of intuitive, really. But anyway, CDK destroy, what that will trigger is the cleanup of all of the infrastructure related to this application. And if you happen to do CDK destroy and you realize, oh, I need the infrastructure, I need to do some more experimenting with it or whatever, then it's just simply CDK deploy. And this is something that I try and remind students about. Certainly, if the infrastructure that you're creating is incurring any kind of costs as it's up there, even if it's not being used. For example, if part of the infrastructure is an EC2 instance, and even though you're not using the EC2 instance, as you know, you're still being charged. Well, rather than letting it there, just do CDK destroy. And whenever you do want to go back and use that EC2 instance and the other infrastructure around it, just do CDK deploy, and voila, it's all created for you again. And it'll be in the exact same state that it was just before you did the CDK destroy. Unless, of course, you actually went in and did some manual reconfiguring of it. Obviously, you can't handle that. And there are ways, like part of your infrastructure might be an actual database. You can tell it, well, destroy all the infrastructure except the database. That's something that might be relevant, but so this is the structure of a CDK project. This is kind of the scaffolding that the CDK init command does. Now, there are really only two parts that we're interested in, and really there's only one part in this lib folder. But if I just go through it one by one here, in the bin folder, all that goes in there, sorry, there tends to be only one TypeScript, in our case anyway, TypeScript file there. And the code in there, there's usually only about 2 or 3 lines of code, but what the code does is it creates an empty CDK application, and then it adds the stack or stacks to that application. And that, as I said, that tends to be only 2 or 3 lines of code. So we rarely have to go in there and make changes. So there's nothing terribly interesting here. It's inside the lib folder. That's where you put your code describing the stack or stacks that make up your application. Now, if you only have a single stack, then you tend to only have one file. If you have multiple stacks, you tend to have multiple files. So it looks like this, I only have one here. And it doesn't really matter what you call, there's no requirement to have stack in the name. But it's inside this file is where you put your code describing the infrastructure, which we'll see in a while. So we'll spend a lot of time coding that. The rest I'm not going to talk about because we won't go near them. And so this is my CDK project. And when you go CDK deploy, for example, what that command does is it first of all actually goes to this file here to find out, well, what am I going to deploy? And this code will tell it what stacks make up your app. And then it actually obviously looks at the stacks then to work out what is in a stack and uses that code really to generate the CloudFormation template. So we refer to this as kind of the entry point of our application. So I said, if I just go back a couple of slides to the, where is it? Yeah. An application is made up of stacks. A stack is made up of constructs. A construct is made up of resources. I want to just briefly talk a little about this construct idea. So there are 3 types of constructs, which are called L1, L2, and L3. We will mainly be using L2. So constructs in the CDK sense now, these construct structures, I'm tempted to call them constructs, but that just doesn't make any sense. So I'll use structure even though it's actual code now, right? It's not a structure from a data point of view. These construct structures, what they do is they create the actual infrastructure resources. And there are many of them built into the CDK framework. Right? They come with the framework. You can actually create your own constructs, and we will see that down the line maybe. But there's a lot of them built into the library. And there are 3 classifications of these constructs. An L2 construct, it will have the effect of creating a number of infrastructure resources. And the 1 to M here, that's what I'm trying to get across. An L2 construct, one L2 construct, or one instance of an L2 construct, because you may have multiple instances of the same L2 construct in a stack, but one particular instance of an L2 construct, it will have the effect of creating multiple resources, infrastructure resources in the cloud for you. And that's kind of the whole point behind this, that rather than you having to write a lot of code to create your infrastructure, programming one instance of an L2 construct will create multiple resources for you, infrastructure resources for you. That's this whole kind of productivity thing that I was alluding to there. Whereas an L1 construct, and again, there are a couple of those, we don't see many of them actually, but an L1 construct, there's only a one-to-one relationship. So if you had 3 occurrences of a particular L1 construct in a particular stack, then it would create 3 pieces of infrastructure resources up in the cloud for you. So there's not a whole lot from a productivity point of view to be gained by using L1 constructs, but you may have to, depending on whatever type of resource, infrastructure resource you want to create. L3s are better than L2s. L3s tend to be based on kind of recognized design patterns associated with, you're doing a module called design patterns, but these are design patterns related to creation of cloud infrastructure. You know, that there are patterns that have developed over time. And these L3 constructs, I don't think there are any L3 constructs that come with the CDK framework. The kind of open source community have developed L3 constructs for us, which of course we can use. They're open source. But we mainly use L2 anyway. And clearly L3, an instance of an L3 construct will create a lot more resources, pieces of infrastructure than would an L2. You know, so you're gaining in productivity the more you use L3s, let's say. But as I said, we actually won't use any L3 constructs. Okay, it's all a bit abstract. It's when we start looking at actual code, and I'll come back and I'll mention about L1, L2, and hopefully it'll be a little bit clearer. Checking my watch again. I'm probably out of time. Now, you know, if you're adventurous, you could, if you want to, go into this lab here. One thing you have to do sort of in order to use the CDK framework, there's no, well, sorry, one thing you have to do is you kind of have to tell AWS that you are going to be using this framework in deployments. What we say is you have to bootstrap your AWS account so that you can use the CDK framework in your AWS account, right? And I did say to you now last week that you have to create your own personal AWS account. It has to be on the paid tier and not the free tier. I'm assuming people kind of have done that by now. And if you want to, you can start into this lab. But it's not essential. We'll certainly get into it next week. At least you could at least get as far as the bootstrapping section of it, just to set yourself up. Okay, I think I've talked enough for today. As usual, I don't give you a chance to ask questions, but I do have another few minutes left, just in case there are any questions that people have for me on this stuff. Hardly, I suppose, but anyway, I'll give you the opportunity. No, okay. So next week we'll actually write some CDK code, and we'll start small, explain it, and take it from there. Right, that's all for today. Thanks for staying with me. I will be in the lab now this week. Sorry, I should really say that. So I'll turn up at the lab this week on Thursday. I'm not going to be doing things like taking attendance or anything like that. So if you worked your way through the TypeScript lab and you didn't have any issues, and maybe by Thursday you may have even started the CDK lab and you're not having any issues, it tends to be the initial CDK stuff that might cause people problems, but by all means you can contact me over Slack and I might be able to resolve them there. But either way, I will turn up on Thursday. So I will talk to you then and also next week. Okay, bye-bye.